Okay, good morning, ladies and gentlemen. And sorry for the sound that you're hearing, because I'm a little bit sick, and therefore I'll be talking a little bit slower than usual. And also, you might hear some strange sounds from time to time, but that's how being sick is. This talk is about my mistakes, or maybe the things I found. I am Jakub Nabrdalik, of course, and I'm a very boring person, so you got a link at the end of this slide to basically check me out, but I do not recommend that. As I said, I'm the boring person. And I work in a much more interesting company where what I do is actually I first work within my clients' teams, where I actually develop the stuff that I design. I design a lot of stuff. And then I teach a lot I give workshops on architecture, on this kind of things. I do audits. So basically I verify the architecture and tell teams and companies what they did wrong and how to get away from that mess, and basically how to move into microservices, usually from a big monolithic application. So with all that, I kind of get to know a lot of different developers, right? And with that experience, I think the first thing I've learned through those years is that there are no mistakes in architecture. There are no stupid people in architecture, okay? When you see something wrong, it's usually because of the bad education, lack of experience. But most likely it's not due to that even, but actually due to really bad managers and people pushing you over. So, and my story starts exactly the same way as that, with me 18 years ago, being the guy who was hired as a student to design an enterprise resource planning system. These systems are large. That system was being built for, like, I think 3 years before it was finished. And so why would you take a student of a third year of the university and basically give him the chance to design this? That makes no sense, right? So that's exactly what happened. And that's exactly what I did. And the system looks something like that, right? But, well, if anybody is surprised, then, you know, what else a student can do, right? With no prior experience. And so I feel very sorry for all the people that were still at that company and had to deal with that system, but that wasn't actually my fault. It was the fault of the managers who put me into, you know, doing this. And I see this happening over and over again in different companies, and managers pushing and so on. So at the very beginning, I thought that this is all due to bad education, because I definitely had bad education. I finished 2 universities, and I don't recommend any of them. And so our books were bad, our teachers weren't so great. Actually, the math was okay or good, and everything else was outdated already, right? But when I started actually teaching and giving workshops and helping companies outside of Poland with completely different education systems, I realized they have the same problems. So it's not only the bad education there's something deeper, right? And so I decided to, like, create a 45-minute talk about this and the things that, if I could return back in time to 2000, let's say, and give myself a few tips on to basically help me design and not fall into those traps, that would be it, right? So that's the thing. Now, this is context dependent. So let's say that if you're building, if you're a game dev, or if you're building embedded systems, that may not apply to you. I built backend systems in technologies like Java, .NET, PHP even, and plenty of languages on those platforms as well. So that applies to me only, right? Take what applies to you and what can help you, but don't take my words as, you know, as something set in stone that you have to apply. So this is from my experience what would help me, but I see other teams as well that they could use that, right? Okay, so sorry for that. As I said, I'm a little bit sick. So let's start from the beginning. Well, the first thing I didn't realize back then was that there is no such thing as a good design or bad design. It's all about whether the design that you have, and I'm talking about the architecture here, is optimized for what you want to get out of that system, okay? And therefore, you can see a good design, that is system which is very nicely designed, right? Which performs very, very bad because it isn't optimized for what you want to get. And the interesting thing is, when I asked the different teams about, you know, what is the system that we have here optimized for? If I have 5 people, I sometimes get 6 different opinions on that. And that describes and explains that basically nobody knows or nobody is sure, or the knowledge is not shared. And this creates a huge problem, because if you have, let's say, 15 people working on a system and they think in different terms of what they should optimize for, they will build the different parts of the system, taking different assumptions, right? And this will fall apart. So when you think about it, what should you optimize for? And a lot of different developers say stuff like, okay, performance, or maybe the system should be scalable. And I've already worked in companies which really had a lot of servers and a lot of traffic, but most of the companies that I work with actually don't need that. And when you look at why our systems are slow, it's not because, you know, well, the design was wrong and, you know, the performance cannot be any better and we just need 10,000 servers. No, it's usually something like, okay, we fucked it up. And what we did wrong was, for example, well, the database indexes, we're not hitting them, right? Or maybe the data structures that we use, including the design of the database, right? Maybe we got that wrong. But if you do not get anything wrong, the servers we have today are quite fast, right? So it's not so much about, you know, we need to find a clever design to keep our system performant, but the other way around. We need to learn how to not do something really stupid on this so it slows down. And most systems do not have to be optimized for performance. They just have to be not fucked up from a performance perspective, right? And if you don't believe me, take a look at this. This is a CPU from 1975 running Doom. Okay, it's mostly Wolfenstein instead of Doom, but it's running Doom on a calculator on this CPU from 1975 powered by potatoes, right? So why would you need 100 and thousands of servers if you can have something working like this, right? So I know, you know, this should be funny, but the point is, if you don't do anything stupid, the system should be fast enough, okay? Now, the stupid assumes also that, you know, your architecture doesn't try to break the laws of physics, like, for example, the speed of sound, the speed of light, right? But we will talk about that. So when you have to choose something that you're optimizing for, and you don't know what to optimize for, don't choose performance. Just don't do stupid stuff. Instead, choose something else. And people usually don't know what else they could choose from, you know, what do we optimize the system for? Well, from my perspective, the most popular options that you should consider are maintainability, which means how much time will people spend on keeping this alive, and extensibility, which is how easy it will be to add new features. And if you optimize for those 2 things, then you have more time to add new business value. And the business guys, they love that, right? So they'll pay you a lot of money. So it makes a lot of sense from the perspective of every single developer and from the perspective of business to just not spend too much time on maintaining this stuff, right? Now, what does it mean? Well, a lot of different things. For example, you cannot have too many bugs. So you have to be good at test-driven development, for example, consumer-driven contracts, stuff like this. Then you have to have modular architecture, so you have extensibility and so on. Now, if you are a startup, there is one more thing you have to be aware, and that is maybe you should optimize for flexibility, which means that if you are in a company that searches for its market, basically doesn't have the strong market position yet, then most likely you will change what you do within a year or even within 6 months, right? So when you do that, when you're in a startup, basically optimize for being able to change the path, or basically to reuse components and build something completely different. Think about it this way. Mongo Corporation, okay, wasn't MongoDB Corporation. They weren't building a database before. And then they did a pivot and basically decided, okay, we are now building the database because whatever we were building before doesn't sell. So that happens a lot to startups. So you have to think in those terms, okay? And you have to choose one thing or maybe two things. In maximum, you have to choose three, and that's over, right? If you choose everything, there's no such architecture that you can optimize for everything, right? An architecture optimized for everything is architecture optimized for nothing. So that's the first thing, and write it down, make it visible to everyone so they know, okay? Otherwise, every single person will build something different. Now, when you have that, the second thing I didn't understand back then is that there are different flavors of architecture, and they are not correct or incorrect. They have just different benefits and disadvantages, basically, right? So these days, the most popular ones are modular monolith, which is a single app with modules. There is distributed synchronous system, which is just microservices talking through REST, and that assumes independent deployment. If you don't have independent deployment of those services, then you don't have a microservice-based system. You just have distributed monolith. And then the last one is most popular is the event-based distributed system, where you have some kind of a message bus or queue. Now, there's a lot of different talks on the benefits of each of those approaches, right? Now, there are not too many about the bad stuff, about, you know, the bad side of it. So let me talk you through what happens when it goes wrong, or basically what you have to consider, because all the three of those are okay, right? It depends on what you want to optimize for. There's no such thing as, you know, the microservices are always wrong, or modular monolith is always wrong. No such thing. It's all about what you want to achieve, right? So here are some problems with the modular monolith. Well, the first problem is that in such a system, you have a big risk of deployment. So basically, no matter what you do, okay, when you deploy this to production and there is a memory leak, the whole thing will go down, right? So if what that means is that companies, what they do usually, they decide to not to go to production too often. So they will say, okay, let's make a deployment once a week. And that there's a whole huge stress with this, right? Because it's a, you know, it's a risky thing, because, you know, all the developers were committing here, and we have 100 developers, let's say, and they were building the system and so on. So if you cannot handle that stress, and nobody can handle that stress, but if you can, if your business cannot handle that big risk of deployment, don't do modular monoliths. Don't do monoliths at all, okay? The best thing about the microservices is that you don't have that problem anymore. Okay, the next problem is that there is a broken window effect, which means that, you know, to have quality, you have to have self-discipline. So basically, all the people that are not maybe not on the same level, but at least at some level, and they try to control themselves to keep the code looking good, right? Now, what happens when you have one product owner which pushes everyone else and basically forces everyone into like a super speed mode, when they don't care about anything, they're just trying to show some feature on a demo or something like that, right? They take shortcuts. And if you allow for shortcuts, if they allow themselves for shortcuts, you have a broken window effect, because that part of the code looks bad. And when that part of the code looks bad and you got another developers working on another part of code, well, that propagates, and that's the big problem. So what that means from my perspective is that if I have a very, very good team of senior developers only, then I can build a monolith with that. But the moment that I have the average developers or an average team, right? And the more people I have, the less appealing the modular monolith is, because I will have that broken window effect. And this is the reason why most of the software actually goes to hell after some time and looks very, very bad. So be careful with that. Now, with monoliths, it's very easy to break the architecture, because, well, there are not too many controls over the architecture in terms of, you know, things that will stop you, basically. So so you can break the architecture easily. With microservices, for example, that's not the case because the single developer will most likely not have access to all the different repositories. So they, even if they wanted, they can't do that, right? Now we can mitigate this. We can use things like, for example, ArcUnit, which is a nice library, which will help you because there'll be tests for the architecture and they will break and to build when the developer breaks the architecture. But that's the most you can do, right? And those tests, if you don't have a good flow with reviewing the code and basically stopping the pull requests which are incorrect, then some developers will sooner or later take those tests out, and then you're back to breaking the architecture situation, right? So you have to be very careful with that. It also means the architect has got to communicate a lot. You have to go over to everyone to make sure that they understand what's going on with the architecture, so they don't have to break it. Now, the next problem is that this brings limited technologies, right? So you cannot have all the different technologies, and they cannot evolve as fast as in a distributed system. So if you decide to use Hazelcast or if you decide to use Kafka, you're stuck with it, right? Well, maybe Kafka wouldn't be so used in the modular and monolith, but anyway, the situation stays. So the problem with that is that after some time, people will leave the company because they get bored with those technologies and they don't want to work with them. And the people that will leave are actually usually the best people, right? So from a perspective of a long-term project for a company, if there are a lot of changes and basically it's a crucial software and it evolves, the monolith is a very risky stuff, right? Because we cannot change the technology so fast. Or you have to make sure that you make it possible and basically you build those abstractions and you assume that you will be able to change this technology whenever there is a new version, whenever we need it, right? Or you're limited by the people that you want to, for example, hire. So it's a company-wide problem, but it's an important one. And it's also an important one because when I work for a company with a monolith, I know that there'll be like a point in time when I'll get bored, right? What happens next? Now you know the answer, right? So, but this is, all those problems are like really important ones. But the biggest one is that not too many people actually understand and know what a module is, and that's a big problem because we're building a modular monolith here, right? And the reason for it is because nobody writes about it. There's a huge amount of books. There's, for example, this book by Neil Ford, which is the basics of the architecture for the engineers or something like that. And the interesting thing is, he mentions that, well, the other books and literature doesn't give you a definition of a module. And then he also does not give you the definition of a module. So I think this is like everybody's playing games with you, and definitely with me. When I went 20 years ago, like, if you don't have a definition of a module, how can you build modular systems, right? So I'll give you my definition of module. The reason why Neil Ford and Mark Richards doesn't give you that in their book or in any other book, the reason for it is because it's very difficult to decide for everyone. But I don't have to be correct. I'm in a position where I just have to help you a little bit, and I don't even have to help all of you, right? This is back, the stock is directed at me, right? Back in 20 years ago. So that means that I can give you something that worked for me, right? So here's the definition of a module that works for me. It's not a set in stone. It doesn't apply in all contexts, but it works very well for me, right? First of all, the module has got a single responsibility, and it's a responsibility for a process, which is a verb, not data. That's important, and we'll talk about it later on. Then the module is a vertical slice, which means it's got all the layers from the database to the API, even the Spring controllers as well, to the UI sometimes, right? Then it's got its API. And you can identify this API. It's a single place for the API, and it's got collaborators, so you know who the module depends on, right, in terms of other modules. It's got its own database, which means that it's got its own tables of collections, and so you cannot do any queries, any reads or writes to that database. You always have to talk with that API of this module. Now that changes a lot, and it's the most important part. And the next stuff is encapsulation. Every single class of this module is hidden except for the API. So you can't touch it. You cannot do anything with this. But the benefits of that means that you can refactor the whole module without changing the API and not thinking about that you're going to break anything. You're not going to break anything. You got its own data, right? And then you have the classes, and nobody's touching those except for the module itself. So there are big benefits of that. And if you do domain-driven design, then the module is within a single bounded context. There are never two bounded contexts within a single module. However, a bounded context can have several modules or even several applications, okay? Now, if you build modules this way, a module is a candidate for microservice, right? And I got some videos and slides about, you know, how to code this and in a natural way on the JVM. So I'll leave you with those links, but we'll move on now. Okay, this is the definition that works very well for me. So that brings a question, and when people start designing using that definition of modules, they have a problem with how small those modules should be. And I'll give you an example to explain the problem. Now, let's assume that you have a software which has got to once a day send invoices to the clients, right? And you got some kind of a module which calculates the cost, right? Now, everything else, you have nothing else, so basically you design the rest, right? And most of the teams and most of the people would actually create a single box, say, okay, this is a module responsible for creating an invoice, that's it. I'll take the costs, I create the invoice, I'll send it over, right? That's a huge module from my perspective. And the reason for it, because if you think about what's going to happen inside those invoice module, there'll be a lot. So you will have to think in terms of, first of all, you have to understand and think about what's really an invoice. So what are the costs there, right? So you have to understand the taxes, you have to understand the billing, right? So you basically have to learn about the law. Now, the next problem that you have is you have to create a file. Usually an invoice will be sent as a PDF, right? Now, that means that you have to learn a library for creating PDFs. And it sounds like a very simple thing. And it's not. It takes a week because all those quirks and problems with the PDF generation, right? Then you have to send it through the email. And it sounds like another problem which was solved thousands of times ago, already, right? So it's simple. But it's not, because if you don't know how Spring integration works, or maybe if you don't know how Apache Camel works, then you have to learn those libraries to write that single line of code that will actually send it over as an email. But you first have to do a lot of research and learn the documentation. So if you think about it, what happens is you have different areas of knowledge, and you have to put those areas of knowledge into your head. So you have to learn those things, right? Why not build 3 different modules for that instead? Now, this will have the benefit that you can have several people working on this. But another benefit is that when you, single developer, will work on this, you'll have less to think about, right? And if there is a bug in the PDF generation, and you go back there in half a year and you don't remember shit, then you go back there and you have to basically learn back those small API of that library instead of the whole taxes and the emailing and everything else, right? So the modules should be as small so that, you know, when you split a module into 2 parts because you have a process, and those 2 parts can be implemented by 2 different peoples with different areas of knowledge, basically, then you should do it. You shouldn't split a module when both people who would implement those 2 modules would have to have the same knowledge. That's basically my heuristic for it, and it's very simple. Okay. Now we all know what non-modular monolith looks like, and it doesn't work very well. So we're going to skip that part, but Ian will move to the distributed synchronous system problems, right? So the one with the microservices with independent deployment. First of all, you need to take a speed of light into account, which means that you cannot have, basically, you cannot do too many calls, okay? That means that you cannot have consistency, like strong consistency. You have to go with eventual consistency, and we'll talk about it later on a little bit. That requires DevOps, which is developers operating the system on production, because now on the operations side, there'll be too many things running and going on, which means that, well, the situation is going to get very complex. So if you think you can still have an operation team that will handle all of that, no, sorry for that. Now, it requires a team for tooling, because sooner or later, when you have several teams working on a microservice-based system, synchronous distributed system, then the same problems will have to be solved the same way. No matter how many different frameworks you have, tracing has got to be done in the same way. So you got to, sooner or later, somebody will have to do it. And most likely you will lose a team only for building tools, right? Not all the companies can afford that. Then you have communication efficiency, which means that, you have to build read modules, and we will talk about this. And then you have complexity of the communication, which means you will have to retries, fallback, circuit breakers, and you will have to learn how to do the transactional outbox pattern and what it means to build resilient system, right? And if you don't do observability first, which is if you don't think in terms of how you're going to observe and basically verify the system as it runs on production, right? Then you will not even know that you have those problems. And that's very important. So you have to learn that as well. And this is a big number of problems. But then there's another one, which is if you build non-reactive system, so you don't use reactive programming on frameworks like Akka, which are reactive by nature, then you will have suboptimal CPU usage, just because right now you will have a lot of different thread pools and different applications with different thread pools, and you cannot expect every single developer to understand how to optimize those. That doesn't work in practice, okay? And you cannot do end-to-end tests anymore. So you have to drop the pre-production environment for end-to-end testing, and you have to go into consumer-driven contracts and learn how to test each of those services alone, right? And then we have event-driven systems. And the event-driven systems also have problems. First of all, somebody has got to do the PhD on the message bus, because it will break, and you will break it, and you will do a lot of different strange things, I mean, you developers with it. So you have to have somebody who reads all the documentation, and these are not simple systems, okay? So if you cannot have a single person or a few, because you don't want to have a bus factor of 1, then you shouldn't do it, right? Then it creates a lot of chaos, because people do not understand what an event is, right? They do not understand that there are public events that should go between teams, and the team level events that are within a single team and its microservices. And there are even private events, an event which is sent from that microservice to itself, just as a storage option when you have a persistent message bus or event bus, right? And then people do not understand that event-driven doesn't mean event sourcing, doesn't mean event storming. All those terms, very popular by the way, have event in them. These are not the same events, and you have to remember that, because otherwise it's a problem, right? Now, just for you to remind you that the event-driven architecture, or event in event-driven architecture, this is about communication. This is a communication pattern. Now, event sourcing is a persistent pattern, right? Sometimes these two events can be the same event. Most likely they are not, and they will evolve in different ways, okay? And then you get event from event storming, and this is a business event. And you don't translate them one-to-one usually, even if you start with something like that. So when we have all of this, how do actually modules and microservices communicate? And there are only 3 ways to do it, okay? And that's very simple. When you have 2 modules or microservices, because it works exactly the same with both of them, you can have a query. And a query is a question, okay? So it's a synchronous by nature. Find available cars, for example. You can have a command. A command means that you're sending an intention, or basically intent, do something for me, right? Like calculate cost. And then you can have and this can be synchronous or asynchronous, depending whether you allow the other side to say no, or whether you expect it to always do it, right? And the event, that's in the past tense, that's stating a fact. This is asynchronous by nature, because you're only talking about things that happen on your side, so there's nobody to disagree with, right? So that would be an event like car was rented, right? Past form, it has already happened. So when you have those 3, then you have to understand how to actually model with them and how to actually write code with this. Take a look at this example. This is a car finder. Basically, the user is searching for nearby cars, and we have a microservice here, or a module. It works the same way. Let's say it's a module, car finder, right? it has got the logic for searching for cars, but it needs data, and it needs data from two different modules: car rental, which has got the list of available cars, and locator, which has got all the locations of those cars. Now the problem is that if you have to, each module has got its own database. It's all tables. You cannot do any join. If you didn't have modules, that would be like select from one table, join in the other table where car is available, and that's it, right? Now that's not possible. So what you can do, you can call the car rental and you can call the car locator. However, this will be very inefficient, because if you call car locator and say, okay, give me the nearest cars and I'll check whether they're available or not, that will be 50 cars, and then you're sending those 50 IDs to car rental, which means there'll be a query where you have the ID within 50 of those IDs, right? That's a very inefficient query. And it's more similar to 50 queries, okay? So you can do it. This approach of using those queries when you have different databases and when modules have different tables, that's not possible anymore, okay? If this is our microservices, that's not possible anymore as well, because, well, these are different microservices. They have different databases. So how can you deal with this, right? So the answer is there's a thing called data locality, which means the data should be local to the service or the module that answers the question if you want to do it very, very fast, which means you need 0 remote calls. So how can we do it? We can change every time you make a query. You can turn the arrow upside down or the other way around and basically send an event instead and duplicate the data. So in this situation, let's say that locator would say car moved to car finder, and car rental would say car was rented, car was returned, and then you can store that information in your database. This is usually called a read model, because changing this makes no sense from the car finder. It doesn't control that information. It just has that information, so you can read it very, very fast from a local table, right? And it can be optimized so that these data structure, the tables or collections, whatever, they look exactly the way they should be returned. So it's even faster than if you had a join between those two tables in car rental, car locator. Now, when you have that, you can return the answer to the user directly without doing any other queries. So only on that local database, and that's a single query, which is very, very fast because the structure is optimized for it. So that's events, right? And it works the same way, whether you're building a monolith system or microservices. In microservices, you don't have any other option. You have to do it this way because of the speed of light. You can't be faster than the speed of light. So basically, you'll have to do it. These are different machines. In modular monolithic system, in theory, you could do it the other way around, but the queries will be very inefficient. So you have to do it anyway. Okay, if you want to have modules, as I define those. But that means duplication of the data, right? Is that a problem? And it turns out it's not anymore. If you have, if all those modules have their own databases and they talk with their own databases, and you talk with those modules through the API, never talk with the databases directly, and you can have a transaction over all of that, over interaction with all the modules, because it's a monolithic system, right? So the data doesn't go out of sync. That's important. Now, so we saw the events and the queries. With commands, commands are an intent, right? And the problem with commands is that whenever you say something from one module to another, let's say car rental says something to cost calculator, then you have to understand the process on the other side. Now, that may make sense on the very beginning when you have a small team and not a lot of people, but if you send a lot of comments, so basically your module or your microservice tells a lot of different modules what they should do, and there are different teams working on the same system on those modules, sooner or later, you will get out of sync, which means you will not understand their processes, okay? So if you don't understand their processes, you cannot tell them what to do and when to do it. They should be able to decide about it themselves. And also, you shouldn't need to refactor your code just because the logic in their module or the requirements for their module change, right? So commands are great, except when they aren't, and they aren't great when you have a lot of teams. So what we can do, instead of, again, using commands, people turn to events, because then you say something like this. Instead of calculate me something, the car rental would say car was rented, and the cost calculator has to actually decide whether it wants to calculate anything on that event or not. And I'm saying event here, but you don't need an event bus. This can be a direct call in a monolithic application as well. The benefit of events is that you only base your logic on your local data and everything you control from the car rental perspective, right? You will never say something which is not true because you control that process of renting the car. Now, so that makes it very stable in terms of, no matter what kind of refactoring and changes come within calculating the cost, the statement car was rented will always be true from the car rental perspective, right? So it's much safer, basically, to do that when you want to work with several teams. And in large, this is the reason, one of the reasons why for very large systems, actually, this is a preferred method, at least when communicating between teams. Okay. So the problem with this approach is that you will have to do some kind of a baseline from time to time, which is, all the people that do the theory on that say, like, those events, they never change, right? They're immutable. So basically, you never have to create them again and change them. And so you can store them, and maybe you can have even persistent event bus, and it's there and it's perfect, right? The truth is that's not perfect, because if you make an error in car rental and you actually were sending the wrong information, so basically I didn't have a field, the field was null, or maybe I didn't calculate something correctly when I was sending that event, so there's some trash data in this, I will have the data that is not usable from the cost calculator perspective, and I will find out about this about a month later when I need to calculate the invoices, right? Something like that. So what happens there? You will have the situation when you will want to send all those events again to cost calculator, right? And that's a problem. First of all, that's a problem because if you have a persistent event bus, then you're going to have those events again, just a little bit different with proper fields and so on. But if cost calculator has got its own read model and a database, and it's idempotent, then what happens? Like, it will not accept those events again. Then you have to clear the database of the cost calculator and then show those events again. So basically, this kind of a synchronization due to a bug that happened before will be necessary. And even though I quite often hear that, this shouldn't happen, like this shouldn't be the case. But it is, it happens, right? We make errors. So basically, you have to be prepared for that, right? Now, this all brings us to another problem, which I already mentioned a little bit, that modules and microservices should not be responsible for data. They should be responsible for processes. And being responsible for data looks like this. This concept is called data ownership, and was called data ownership 20 and 30 years ago. If you think about a system which handles moving cars, then you would create a car module. And when you have a car module, then what happens next is you got a lot of different methods which all concern a car, right? Now, this is a bad module. This is a bad module because it's not responsible for a process. It's responsible for data. But that makes no sense because it will be huge sooner or later, and you will have a lot of problems refactoring it, right? So don't think about that. Now, but it's still a third or fifth normal form on the database level, which is cool. So how should we actually build this? Well, it turns out that you should think in terms of processes. So what do we do with this car or in this system? Well, we got the rentals, we got the returns, we calculate the cost, we check for the nearest car, and so on, so on. So then instead of data ownership, each of those modules turns into something called single point of truth, which means that only one module, this is, for example, car return, can say car was returned, or car rental can say car was rented. There's only one of them saying the truth, because otherwise you would have a problem deciding which one was correct and which one was not. But apart from that, the data is public, okay? So this is usually used with events. And again, that's the reason why a lot of different companies go into event-driven architecture. But that's important because then your modules are small, they don't change too often, they change only when the requirements for that process change, and it's easy. But there is a lot of duplication of data, even when you're building a monolithic system. And the data duplication is not a problem, turns out, right? So we are running a little bit out of time because I'm so slow these days due to being sick, but I'll point out a few more things. The first one is that you will have to have some kind of database locks due to being able to protect invariants, which means, you know, the being something that is always correct. Like we cannot rent a car which was already rented, right? And these invariants will define basically what databases you need inside those microservices or modules that you have, because it works the same way. So be careful for that. And then the next problem is the orchestration and choreography. And basically what you need to do is you need to remember that you cannot like synchronize your state, and you cannot try to synchronize your state. And orchestration, which is a great approach when you have a single team, doesn't work with multiple teams so well, because it's the same problem with commands, that you have a single module or microservice talking with each other to other teams and basically telling them and those microservices what to do. That's orchestration, right? Now, when those modules evolve and they belong to other teams, you will not be able to do that anymore, and so it will break quickly. So instead of that, aim for choreography whenever you build a system with more than one team, or whenever you build a distributed system. That's also important, because then this kind of reasoning is not necessary anymore, and you don't need to know what happens when the car is rented. You only need to understand your part of the job and say what you know to everyone else, and they can ignore it. And that's all you need to do that, right? So I got some links to the talks which are going much deeper into that part. But since we are running out of time, I think let's move over. And one more thing which is necessary, and I have to point it out because due to the COVID, you know, we all remember how the system broke, which was responsible for, you know, when you were getting vaccinated, right? So here's the thing. When you design the system, you have to think in terms of different SLAs and different requirements for that system from different perspectives of different processes. And you will find out that when you have several different requirements and several different users, it might make sense to split that system into two. And I'm talking about, you know, getting another application, even when you do a monolithic application. Here's an example. For the patient registrator system, we had the patients which were trying to register for vaccination, and that means there is a low SLA because they can do it tomorrow, but there is a potential distributed denial of service attack because there's plenty of them. And in terms of the nurses that need the data of the patients to be able to vaccinate them, you got a fixed number of requests per second because there's only so many nurses, but you need a high SLA. You don't want to lose that, right? Now, what happens when you have a denial of service attack? The system dies. What happens for the nurses? They can't do their job, which is exactly what happened. So in such a situation, you need to do something like that. You need to think in terms, okay, this system can die, but it needs a low SLA, and this system needs to have a high SLA. If I combine them two, I will need to provide a high SLA for both modules, let's say. But when I have those two applications, I don't have to do that. So basically, the patient registrator could do its job, then say patient was registered to patient injector, whatever you call it, and then you have a different SLA, and you can provide that different SLA without any chances of this being dying under denial of service attack if you do throttling here, right? So split applications into different, when they have different non-functional requirements, into different applications to provide those, even when you're not building a distributed system, because this will be easy. And this didn't work too well. That's it. Okay, I think we are running out of time completely, right?